we have a rational expression divided by another rational expression. And what are rational expressions? Well, they're just big fractions. And how do we divide two fractions? Well, I don't divide fractions. What I do is I take the first one just like it is, and then I multiply by the reciprocal of the second fraction. Now, before we do that, this question is going to ask us to simplify, but it's also going to give us this part here, and it's going to say x cannot be equal to. So right now, we have to look at what x cannot be equal to. We're going to get two numbers here, and we're going to get two numbers here. So before we do this division, let's go ahead and do all of our factoring. So the first fraction, x squared plus x, this is just the greatest common factor of x that we can take out. So I will have x and then x plus 1. Now that numerator is factored completely. Down here we have the difference of two squares. So that's going to be the conjugates, x plus 2 times x minus 2. All right, we're going to divide by, let's factor this. We have another difference of two squares up here, x squared minus 1, so that's going to be conjugates again, x plus 1, x minus 1. And then down here is what I call an easy one, because it starts with the number 1. So I can just go straight to my two binomials, and my first two are going to be x and x. That's how I get the x squared. The last two will multiply to give me 6 and add to give me 5, so that's 3 and 2. Plus and plus. All right. Before I multiply the first fraction times the reciprocal of the second fraction, I need to look at what would give me a 0 in the denominator. So right here, a -2 plus 2 would give me a 0. Right here, a +2 would give me a 0. A -3 would give me a 0, and a -2 would give me a 0, which I already have that over here. So I'm going to go ahead and put that here. X cannot be equal to -2, +2, or -3. All right. Now, let's go ahead and let's turn this into a multiplication. So let me see if I could do a little internet magic here. Nope, I cannot. So I'll just write it down again. X times x plus 1 over x plus 2, x minus 2. That just drops down. And now I am going to multiply times the reciprocal of this fraction. So x plus 3 in the numerator, x plus 2 in the numerator, x plus 1 in the denominator, x minus 1 in the denominator. And I probably shouldn't have done an x from my multiplication symbol. I probably should make it a big dot. All right, now, at this point, what would give me a 0 in the denominator? Well, this is still the same. This is -2, and this is +2. But I could also get a 0 down here with a -1 or a +1. So I have to include that in my answer over here. X cannot be -1, x cannot be +1. Okay, some questions won't ask you this part, but it's good to know. All right, now, just like when I multiply fractions, anything in the numerator will reduce with the same thing in the denominator. I should clarify, any factor in the numerator will cancel any factor in the denominator. So let's see what they are. I have an x plus 2 and an x plus 2. I have an x plus 1 and an x plus 1. All right, here's what I'm left with. x times x plus 3 in the numerator, and in the denominator, x minus 2 times x minus 1. Remembering that when we multiply fractions, numerator times numerator, denominator times denominator. Now, let me clarify what we cannot cancel. Okay, see this x with this x? We cannot cancel those because this x is part of a binomial, and this x is part of a binomial. You'd have to be able to cancel the entire binomial, the entire factor. So this is our answer. I will put a box around it, and I will put it up here. So we have x times x plus 3 over x minus 2 and x minus 1. Okay, noting that the things that would give me a 0 in the denominator, my domain restrictions, right, it's already there, and this one is already there. Okay, so these are also considered domain restrictions. I'll write that here. My domain is every number I can plug in for x. So in this case, it's all real numbers except this one, this one, this one, this one, and this one.